Okay, that sounds a lot worse than it really is. Ready? Solving a right triangle just means finding all unknown sides and angles. Ooh, so far we've only been doing sides. But we can use a special thing to find unknown angles too. So, when we have a right triangle, it's called the inverse, tangent, sine, and cosine. If you know the value of any of the ratios, you can use the table or the calculator to find the angle measure using the inverse button on the calculator. So for example, let's go to our book. $9.25. So let's say, let's say you have an unknown angle measure, but you know the leg opposite it and the leg adjacent to it, so you divide and you find that ratio is 0.9657. So which ratio did I use? If I had the opposite and the adjacent, which ratio did I use? Opposite and adjacent. Tangent. And I found out when I divided those two side lengths that the tangent ratio is 0.967. If I have that number, I can find out the angle measure. Well, let's find 0.967 under the tangent column. Take a look. Look it up. What angle measure is that from? 0.967. Well, put your calculator down. You're using the book right now.
44.
So if I look all the way down here, here's 0.967. There's the ratio, right? The tangent ratio, 0.967. That means that came from a 44-degree angle. Remember, I told you, it doesn't matter if you have a little tiny right triangle or a right triangle the size of this room. If you have a 44-degree angle, the tangent ratio is going to be 0.9657. So if you know this ratio, you can find the angle measure from the table or from the calculator. Okay, so that's what you're doing today. So let's practice this a little bit, first of all. Let's do it on the calculator too. Let's go look at number 1 up here. Number 1, we found out that P is 11.34, right? And we know that the bottom number is 12. So let's say I need to find the cosine of whatever angle that is going to be 11.34 divided by 12. What's 11.34 divided by 12? Do it on your calculator and find out. What is it? Okay, so I'm just doing 11.34 divided by 12, and I get 0.9545. Now, I want to know the angle measure. We already know the angle measure, don't we? What is it? They gave it to us up here. 19 degrees, correct? Well, if I know the cosine ratio, I can just do this. The cosine inverse 0.945 on my calculator or on the table. I could go down the cosine column until I found 0.945, and guess where it would be at? What degree measure? 19. But let's do it on the calculator. So here, you see these buttons right here, sine, cosine, tangent? Look right above it. What do you see? The little -1 ones, right? That is inverse. So I'm going to push those buttons. Blue, see how it shows that? If you're trying to find the angle measure, you're going to stick the ratio number in, which is 0.945, and then you're going to push enter. Oh, I forgot my decimal. That's a problem. 0.945. And it's 19. It's a little bit off because we rounded, but so try it again. Did you get it? So what I'm saying is, if you know the ratio of the two sides, you can use the calculator to find the angle measure. Make sense?
Yeah.
Yes. What are you using? Calculator? Are you in degree mode? Is that an Inspire?
Yeah.
Or an 84? I don't know how to get them in degree mode. So you might have to use an 84. I've got 84s here, I've got 84s over here. There's some in the red bin over here, and all of those up there with the little sticky notes on the front, those are 84s. See on the front, there's little yellow sticky notes, those are 84s.
Thank you.
Yeah. They have the 84 phase plates. Now you have to check that these are in degree mode too before you do it. Are they in degree mode? Mode, degree. Got it? Okay, can I move on? Let's just do some of these together. Basically, all I'm saying is if you know the ratio, you can find the angle measure that it came from. Okay?
Okay.
Use a calculator to approximate the angle measures to the nearest tenth of a degree. Okay, so let's try and find R. I don't know what R is, but I know that the tangent of R is equal to what over what? 8 over 12, so I'm going to find this ratio. And 8 over 12 is 0.67. Now I can use that ratio to find the angle measure with the calculator or the book. Use the calculator and put in the tangent inverse of 0.67, and it's going to give you the angle measure. Yeah? So let's round it to, does it say here? To the nearest tenth. So it's going to be 33.8 degrees. So that means angle R is 33.8 degrees. Now, do we have to do any more work to get Q? What's the easiest way to get Q?
80 minus 90
Yeah. You could just do 180 minus 90 minus 33.8. Or you could really just do 90 minus 33.8.
Why did my calculator get 47? It's in degree, it's in everything. You just got
Did you use tangent? Try it again. Yeah, maybe you use cosine. So that's approximately 56.2 degrees. So angle Q or O or whatever that is, 56.2 degrees. Doable? So I like to do this because as you have to find more stuff, it's good to keep it, I think it's a Q, straight. So if you just write down S is 90 degrees, Q is about 56.2 degrees, and R is about 33.8 degrees. All right, let's do another one. You want to do A or C? So let's find C first. So I'm going to write the measure of angle B is equal to 90 degrees. I need to find the measure of angle C and the measure of angle A. So you guys want to start with C. Okay, if I do C, what ratio do I need to use? Opposite hypotenuse. So which one is that? Sine. Sine of C is the opposite over the hypotenuse, which is 0.6. Then I can find the angle measure by doing the inverse, and we'll see what that is. $36.9 I got. Yeah? Okay, so I'm going to write that down here. I know I have the measure of angle C, which is 36.9 degrees. And then I can just subtract, actually I can just subtract these two. Why can I do that? Yeah, if I take this 90 degrees left, I have 90 degrees left here between these two, right? So I can just do 90 minus 36.9. Or if you don't like that, just do 180 minus 90 minus 36.9. Yeah, it's about 53.1 degrees. We should do squigglies, but I wouldn't mark you off if you didn't. Cool? We have not solved this right triangle yet, but we've done what they've asked us to do. So now let's go to the back side. Okay, I want you guys to do these three on the calculator. Let angle C be an acute angle in a right triangle. Use the calculator to approximate the measure of angle C to the nearest tenth of a degree. So, you just use the inverse button, right? That's all you're doing. They're giving you the ratio. You have to find the angle measure. You could use your book, or you could use the calculator. Did you figure it? Did you find it? I know. I don't know why it's so hard. I got to go down and ask them down the hall. Cool?
Cool.
I don't have any. I got paper towel in that big cupboard there, or you got to go to the bathroom. Or you got to be like Claire and bring your own roll of toilet paper.
I brought tissues today.
Oh. Okay. Now we got to solve the right triangle. That means we have to find all the unknown side lengths and angle measures formed by the water slide in the figure. Round the decimal answers to the nearest tenth. So we need to find the measure of angle X, the measure of angle Y, and the measure of angle Z. I already know the measure of angle Y is 90 degrees, correct? And I know the measure of angle X is what?
42.
So I really don't have that much work to do for angle measures. I can just subtract 90 and 42, and that'll give me 48. So I have all the angle measures. Cool. Now I've got to find the side lengths. So let's find, I don't know, let's find ZY first. So if I'm going to find this side length right here, and I know this angle measure is 42, I could use opposite, hypotenuse. What would I use? Sine. Okay, so I'm going to say the sine of 42 is equal to my unknown ZY over 50. So you're really just cross-multiplying, you're really just multiplying these two things together. But if you don't see that, set it up. The sine of 42 times 50 would equal ZY. What does ZY equal? Correct, 33.5. So I've got that. This is part of my answer. The last thing I need to do is find XY. You have options. You could certainly use the Pythagorean theorem at this point if you wanted to. If we know this is 33.5, let's just use the adjacent and the hypotenuse. So which one am I going to use? Cosine. Equals the adjacent, which is XY, over 50. So basically, again, you're just multiplying these two together to get xy. When you cross multiply, that's what it's going to be. What do you get? Okay. Pardon me? Do you see it? Okay, now, if you were on a test or a quiz, you should definitely check what here in this picture? These two legs have to be what? Shorter than the hypotenuse. Okay? If you don't get something like that, then you could always test that you did the math close to right by using the Pythagorean theorem. Right? If you want to. With the rounding, it might be a little off, but it should be pretty close. Okay. All right, last one. Solve a right triangle that has a hypotenuse that is 9 units long and a leg that is 3 units long. We don't know any angle measures other than the 90-degree one. So this is not to scale, but we'll just pretend. I'm going to call this A, B, and C. So what I need to do is I need to know the measure of angle A, and I know that that's 90 degrees. I'm also going to have to find the measure of angle B and the measure of angle C. So I'm just setting up what I need to find out. Then I could use the Pythagorean theorem to find this third side, but we could do different methods. It's up to you. Okay. We could find angle C pretty easily, or B. What could we do here? Let's do angle B. So, can I get the ratio? Which ratio can I get here? Adjacent over hypotenuse, which is what? Cosine, right. So I'm going to say this is equal to the inverse of the adjacent over the hypotenuse, 3/9. Right? And then you can just put that right on your calculator and find out the angle measure. If you know the ratio, you can get the angle measure using the inverse. So you can put that fraction in parentheses. Wait, okay, well, where did I lose you? Ben, you good? I'm just looking at your faces. I'm just making sure. Is everybody good? Okay. What did you get for that? To the nearest tenth. I didn't round to the nearest tenth, so it should be what? 70.5?
I thought it would be cosine of B equals 3 over 3.
From this angle, cosine is adjacent over hypotenuse, right? So you need that ratio, 3 over 9, and you put that all in the calculator to get the angle measure. Okay? All right, now we can just subtract to get angle C. What is it? 19.5. So we have all our angles. So now, if you write this in here, you have options. You could certainly use the Pythagorean theorem. We need to find AC. Let's write BC is 9, BA is 3. I need to find AC. So you could use the Pythagorean theorem, but since we're doing trig ratios, that wouldn't be any fun. Let's do a trig ratio. Let's go from angle B here. So if I'm going to use angle B, what ratio would I use? Let's use tangent. There's options. Let's use tangent, okay? So I'm going to say the tangent of 70.5 is equal to AC over 3. See what I did there? I'm just using a tangent ratio to find the side length. You could use the Pythagorean theorem. You could use tangent. You could use sine. You could use anything, really. Okay? So here you cross multiply. AC is equal to the tangent of 70.5 times 3. What's it equal? 8.5 is what I got. Now just double check. Are you good? Your legs are shorter than your hypotenuse, yeah? Okay. Are you good? What does it mean to solve a right triangle?
Solve all the angles and sides.
Everything. Yeah. Using inverse, using ratios, using Pythagorean theorem if you want. Okay? That's it.